Welcome back to another session of Physical Sciences, Chemistry again, and in today's session we will look at acids and bases. The last time we spoke about the autoionization, we spoke about Kw, Ka and Kb values, we looked at the pH scale, we looked at pH calculations, and we also looked at the application of Le Chatelier's principle to our acid and base reactions. In today's session, I would like to look at titrations. The terminology that will come up a lot is neutralization, titration, endpoint, equivalence point, and indicator. So neutralization is a reaction between an acid and a base, and when that acid and base reacts to form salt and water, we say they neutralize each other. Remember, we don't say they cancel each other. The one neutralizes the property of the other. When we look at titration, titration is the technique used to determine that neutralization point of an acid-base reaction. So if we have that neutralization reaction, we can actually make use of an experimental method that's called a titration to determine that endpoint, meaning that point where the acid and the base has now neutralized each other to a certain extent. So that experimental method is used to determine the unknown concentration of either the acid or the base. For us to do a titration or to do neutralization, how will we know what's the endpoint? How will we know this is now the product? So for acid-base reactions, we use chemicals to show us that there is now a neutralization. So that chemicals are used, that we use are called indicators, and an indicator is a chemical that changes a color, its color, depending on the pH of the solution, and when we have that change in color, we will then know if it's from the one color over to another color, we know that some reaction has taken place, and we might even, according to the color, know if that was the endpoint or not. So if we look at an acid-base reaction, I said that an acid and a base forms a salt and water. So if we want to evaporate the water, we will all be left over with the salt, and that salt will all depend on the acid and the base that reacted. So in a titration, we observe the color change when that acid and that base neutralize each other. Okay, we can only see the color change if we have the correct indicators. Now, we will talk about correct indicators soon, but for now, you just need to know for every reaction that you have, you must choose the correct indicator, else you will not really know if the endpoint is the correct point. So this, where that indicator will now have a color change, there at that point we know it is the endpoint of our titration. Endpoint doesn't mean it's now the end of everything. It means it's the neutralization point of the acid and the base. And that color change will then be able to help us or give us more or less a rough idea of the pH of the salt that is formed. When we have the endpoint of a titration, that endpoint means that all the reactants have changed to products. So at that endpoint, there's no reversible reaction. It basically means that A plus B has now formed C plus D, and that one of your A or B is used up. That's the only way that we know we now have an endpoint. So this is also known when all the reactants are used up, that endpoint is called the equivalence point. So the endpoint is the point of the titration where the reactants where the reactants have neutralized each other. It will be shown to us by means of a color change, and the equivalence point is when all that reactants are used up and changed into products. So neutralization occurs when a strong acid reacts with a strong base. Now neutralization, I said, we have an acid and a base, and the acid and the base reacts to form a salt and water. Now neutralization, in this case that we're discussing now, if we have a strong acid and we have a strong base, then we also have neutralization. So if we have a strong acid, then we know something with the likes of a pH between 0 and 2. And if we have a strong base, then we know we're looking at a pH of 13, 14. So when a strong acid and a strong base, like any other acid and base, it will form a salt and water. But specifically here, the resulting solution will have a pH of more or less 7. A pH that is actually a neutral pH. When we look at our indicators, there's a choice of 3 indicators that we're going to use for the curriculum. If we have a strong acid and a strong base, and we expect that the salt will be more or less 7, then we must use an indicator that will show a color change in the range of more or less 7. So the best indicator to use whenever we do a strong acid and a strong base neutralization is bromothymol blue. Bromothymol blue will change more or less round about a pH of 7. When we look at the neutralization between a weak acid, meaning an acid that's got a pH just lower than 7, and a strong base, meaning a base that's got a pH of, let's say, 13 or 14, when the two neutralize each other, it will also form a salt. But in this case, the salt that will form will have a pH that is a bit bigger than 7. And we then say, simply because it's bigger than 7, it simply means that we've got a weak basic salt. So the salt that's been formed by a weak acid and a strong base will actually form a weakly basic, meaning it will have more OH minus than hydronium ions in solution. In the case where we use a weak acid and a strong base, the only indicator that we can use here is phenolphthalein. And we use phenolphthalein because we expect a color change around a weak basic pH. The last one that I would like to look at is where we have a strong acid with a weak base. Then if we have a strong acid, we have an acid with a pH of between maybe 0 and 2, and the weak base will have a pH just bigger than 7. When the two react and they form a salt, the resulting solution will have a pH that is smaller than 7. Now, a pH smaller than 7 is anything in your acidic range, but it means that the salt will be a weak acidic salt. For us to see the color change for this, for us to know that it will be a weak acidic salt, the color change should then be at a pH a bit lower than 7. And in the case of a strong acid and a weak base, we will use methyl orange to indicate the color change for us. And this, once again, brings us to the time that we all love. We're going to take a break now. I'll see you after the break.